right, so as we consider this absolute value inequality, I want us to go back. I want us to remember what we did with absolute value equations. When we dealt with absolute value equations, it was important for us to isolate the absolute value on one side of the equation, right? So we're going to do the same thing here. If we've got something added, subtracted, multiplied to this absolute value, we want to swing that over to the other side. So this -2 that's attached through multiplication, I'm going to divide that over. Since I'm dividing that over, that isolates the absolute value. Understand I am dividing by a negative number, so since this is an inequality, I have to flip the symbol. It's now greater than or equal to. Dividing the -2 over the -12, we get +6. Okay, now the absolute value is isolated. I take a look here at the symbol I'm playing with. It's a greater than symbol, so I'm thinking greater than. This is going to set up an or statement for me, meaning my answer is ultimately going to be some sort of union idea. It's frozen on me again. Come on now. Nothing. Hey, there we go. All right, so I set up the or idea. Over here, I'm going to set up one inequality. Over here, I'm going to set up one inequality, and I'm going to solve both. So for the first one, basically I rewrite, the setup I have here. I just take the absolute value bars out. I've got 3x plus 1/2 greater than or equal to 6. For the other side of this or setup, I'm going to have 3x plus 1/2, everything that was inside the absolute value. But this time I flip the symbol because I'm changing the sign on the number over here. Now, a few ways we can go about this. If we're not a fan of the fractions, say I'm solving over here for this inequality first, I could multiply both sides by 2. That would help me to clear the fractions out, meaning I would have 6x, froze on me again, it'd be 6x plus 1 greater than or equal to 12. And as long as I'm at it, right, I might as well work with this guy too. Multiply 2 through. Got your 6x plus 1 less than or equal to -12. So continue with the solving. Subtract 1. We have 6x greater than or equal to 11. If you don't mind doing two things at once, we can do this one as well. Subtract the 1 over. Got -13 there. At which point we divide by 6. X is greater than or equal to 11/6. Over here, x is less than or equal to -13/6. So we've got x is greater than or equal to 11/6, or we have x is less than or equal to -13/6. Part of what we have to do here is solve. Part of what we have to do here is graph. So we've gone through most of the solving. Let's graph out what we have. Let's see what we've got. We've got 11/6, we've got -13/6. For the first one we solved for, it said x was greater than or equal to 11/6. So greater than or equal to 11/6, that would be everything out this direction. The other one we solved for was x is less than or equal to -13/6. So include the -13/6, shade everything out to the left. We talked about the significance at the beginning here when we started solving everything out, and we found that it was a greater than type situation. We talked about the significance of that or idea. Or goes with a union, right? So notice how you've got this interval over here, you've got this interval over here. We got to bring together the union of those two intervals. So using interval notation, this interval I've got negative infinity going up to negative 13/6. We will include the negative 13/6, so I throw a bracket on there. On the second interval, we include the 11/6. That goes up to infinity. And again, we've got multiple intervals, so we form a union between the two. Okay, there's our solutions for what x could be.